Hello, everyone. I'm Ronan Slavin, co-founder and CTO at Cycode. Today, we're talking APIs, WAF, and how AI is changing both the attack surface and defense model. I'm joined by Masham Anand, Senior Director of Product Management at Cloudflare. Masham, quick intro. What do you own and what are you focused on right now?
Hey, good day, Ronan. My name is Basha Manat. I lead product management for what we call discovery, posture, and forensics at Cloudflare. This is within our application security portfolio. Now, these capabilities complement our inline defenses, which is our like market-leading DDoS protection, our web application firewall, bot management, API protection, which we'll talk about today, and client-side security as well. So these are so discovery, posture, and forensics. It's about discovering critical applications, application paths, assets, and so on, doing reactive posture management on them. And then forensics really refers to um, doing investigations of incidents, alerts, and things like this.
Awesome. So it sounds like you're responsible for the full AppSec loop, from discovery, posture, forensics, plus the inline controls. So let's zoom out a bit. Let's zoom out a bit and anchor in what you guys at Cloudflare see every day at the edge. So how central are APIs in the modern web traffic that you see? And then with AI accelerating everything, what's fundamentally different now for attackers and defenders?
Yeah, so we published an annual report called the Cloudflare Radar, which is looking at roughly about 21% of traffic that's actually proxied by Cloudflare. So it's a fairly large data set that we look at. And the interesting thing is that year over year, we see the share of API traffic over all web traffic. It's about 57% today. So it's the lion's share, so to speak, of all HTTP traffic that Cloudflare is actually proxying. So again, API, the topic for today, super critical to understand. And this is, most customers that I speak to are API first already in the way they manage their web presences and applications, so to speak. Now, that being said, the second question that Ronan asked was really around the impact of AI. So again, there are two parts to it. So the first part is again from the attacker's perspective on AI. So in September 2025, Anthropic actually published a report on the first known Gen AI powered attack. The details there are that a Chinese state-sponsored actor used Claude to automate about 90% of the steps in a campaign to weaponize a breach of more than 30 organizations, and actually succeeded in a few cases. Now, the tactics and techniques that they were using are what a pen tester would typically use, but extremely automated with a lot of recon, permuting privileges, privilege escalations, and so on. So the obvious question is this a new beginning in terms of weaponization of AI in the hands of attackers? Now, Anthropic's case study is really around industrial scale use of Gen AI. The more common case is something that you may want to look at, something like the Verizon data breach report, which they publish every year. So in the 2025 survey that they did, again, they study about 20,000 actual breaches and then the root cause behind them. That's the context. And in 2025, after a very long time, they saw a 200% increase in exploitation of vulnerabilities. And it essentially the top category of root causes for breaches happens to be vulnerabilities. And we think this is because attackers are essentially vibe coding exploits as soon as an exploit is announced
Yeah.
in the public, so to speak, when a CV is announced, right? So either way, if you look at Anthropic, if you look at Verizon, the common conclusion here is that, again, vulnerabilities in your applications, APIs in particular, super critical to keep an eye on, and then understand that attackers have AI powering them today and expect a lot more weaponization. So again, that's the attacker's perspective. As a defender, what can you do? So in Cloudflare, what we actually suggest is really defense in depth. So a lot of the application security products, it's essentially looking for all the possible known threats that we are aware of, including things like DDoS mitigation, bots mitigation, API protection, which we'll talk about a lot more today, client-side risks, and so on. So being comprehensive, and then more importantly, under the covers, a lot of the defense in depth, at least from Cloudflare, is a combination of machine learning and rules and concepts like positive security, which we'll talk about as well. Again, defense in depth is the key thing that defenders can do. Rona?
Yeah. So basically, same tactics, but the execution is much faster. So obviously, as security companies, it's on us to equip our customer with super quick solutions. But it does sound that the attackers are actually focusing at the use cases that we knew from before. But again, now they have the power of AI on their side, and obviously from the defender side, there's also lots of potential in harnessing it and bringing this to our side. I would say. Um, Now, if we look at kind of the risk around API and kind of to fix the issues that we're here to talk about today, really like the first path to secure like everything in cybersecurity is to have visibility into what we need to secure. So it all starts with an inventory. And obviously, like your product is excellent in that. So from your perspective, like what's a practical path to have an API inventory that stays current and not just a spreadsheet that you maintain?
Yeah. So when like I said, in my role as part of discovery, the key idea there is that as a defender, you need to know what you're protecting first, hence inventory. Now, the thing is, when you look at API protection in particular, which is mostly what we're going to talk about today, the best practice here is to actually continuously look at inventory. So this idea of continuously cataloging your APIs, uh, tracking them between versions and things like this. And then more importantly, the way Cloudflare does it as a proxy that's sitting between end users and your applications, our particular technique is really around evaluating endpoints that we see using real traffic. So when you go into the Cloudflare dashboard, you'll see anything that we discover that's new. You have the ability to go and look at it, evaluate it, and then save it as an endpoint to make sure that from a developer's perspective, it's indeed rightly categorized, so to speak. So again, API Shield's endpoint management is really the key feature as it relates to this particular topic today. Now, what API Shield actually does, again, it's an API protection product, but unlike Sitecode, it's actually a runtime protection platform. And what it means is that it continuously examines the API traffic. It looks for payloads in that traffic, especially malicious payloads. Also applies techniques like anomaly detection and so on. And then what it comes back with is essentially, I would consider three broad things. The first is it comes back with risk labels. Risk labels are of two flavors. So the posture labels typically refer to things like missing authentication, mixed authentication, missing authorization, and so on and so forth. So those are essentially, think of them as proactive signals, so to speak. We also come back with reactive signals as well, which is like, driven off of anomaly detection, in particular, things like spikes in requests, spikes in errors, spikes in latency, and things like this, which are good signals for you to keep an eye on. And the last but not least, positive security is really one of the key concepts within API Shield as well. So because APIs done right are supposed to conform to the schema that a developer specified for them. So one of the things that API Shield is doing is it's continuously learning schema of your APIs. And one of the default ways of running API protection is to use positive security, which means that any request that doesn't conform to the developer specified schema is automatically blocked. So that's, again, a combination of positive security plus things like anomaly detection, posture labels, and things like this are really the way you want to do it. Again, it all starts from cataloging your API endpoints from in a comprehensive manner.
Yeah, so very cool. So the inventory comes from real traffic that you're seeing from your side. Then we treat endpoints as managed assets, where you put labels that basically like give insights into the things that you see tied to these labels across security and such. And obviously, like in the integration that we're releasing, so from our side, we complement it with kind of our understanding of the code. So where was the API introduced? Who owns it? The change context around it. But if you continue kind of to talk about the use case of securing APIs and managing all of that, so you mentioned schema. So when you do get traffic that you don't recognize, like what do you do first? And B, how do you handle like unknown endpoints safely without, breaking production at runtime?
Sure. So actually, when it comes to comprehensive inventory, there is actually things that Cloudflare can actually detect as a runtime proxy, so to speak. But then there is also things like shadow APIs that are there embedded in your code, like calls that you're making to third-party endpoints and things like that, which are not visible to Cloudflare. So when we say comprehensive, step one, which we are looking to do with Cycode here, is to actually complement what we do at runtime, which is based on traffic, in discovering endpoints and traffic, with what Cycode does, which is the code is your source of truth. So when it comes to comprehensive inventory, scanning your code, figuring out what these endpoints are, including third-party integrations that you have in code, and then especially the shadow APIs that a developer may have instrumented back in the day, but they don't seem to be getting any traffic at this point as far as Cloudflare see. So there's a lot of these use cases that go beyond runtime that is part of discovery. Now, that being said, how does the runtime protection actually handle these so-called unknown endpoints? Again, schema validation is really the first line of defense, so to speak. Any request that doesn't conform to the discovered schemas, you can actually block them. Beyond that, if we do see requests that don't conform to the schema, there is a fall through policy that you can define. And that, again, it could be, you can actually either block if that's what you want to do, or generally you can also log as a starting point for any requests that don't conform to the schema. In general, when customers use our products in the early days of adoption, what they actually do is to log requests, actually log requests that we do automatically, but more importantly, log these kinds of events like uh, fallback requests and things like that don't conform to the schema. Then once they get a hang of what's actually going, perhaps it's some shadow APIs that they need to worry about, tune the system, tune the code perhaps, and then start enforcing it from a blocking perspective. So again, the general flow here is again logging, tuning, and then at the last step, enforcement when developers feel comfortable with the data that they're seeing.
Yeah, I really like this approach. I think you called it positive security. So like having this similar to allow listing that we used to know. So you start with logging, then if you need to tweak kind of your allow listing policy, and then you start enforcing when you feel that you saw enough. And again, like you can start, you know what to expect. So like if there's anomalies, you want to block them by default. Um, we also mentioned kind of several use cases around API, so shadow API, third-party API calls. Obviously, there's many security issues, authentication, and I know that you mentioned that you see 57% of the traffic is API. So obviously, both our customers have a lot on their plate, and I guess like the next challenge is how do we prioritize everything? Engineering time is always limited. So like, how do we know what do we need to fix first? What tell you to do that? And do customers treat the mitigated request that you saw as the signal that says, you need to fix this now?
Yeah, just to put this in context, when you use products like Cycode that are actually looking at code, especially the first time that you scan your code, you're going to literally have thousands and thousands of vulnerabilities that these tools are going to report. And oftentimes, practically as a product manager, one of the things that I also need to do is balance innovation with security. And when InfoSec teams insist that, hey, you need to fix all the vulnerabilities that you find, actually the requirements around this kind of stuff is getting more and more stringent for most companies, software companies in particular. So if you have just say 30 days to fix thousands of vulnerabilities reported by Cycode, where do you even start? Especially if this is the first time that you've purchased a product and need to get a handle on what the Cycode solution is reporting for you. So again, prioritization is the obvious answer. Now, what's the practical way of doing it? Obviously, if you do have Cloudflare turned on as well, like Ronan is pointing out, positive security, blocking requests that don't conform and things like this. That's what we mean by blocking as a first line of defense. But then that gives you a little bit of time to actually examine these blocked requests, see what's going on. But more importantly, it buys you time to actually fix the issues in code. So again, runtime defense is definitely part of it. The other part definitely is when you integrate runtime findings with code level findings, the kinds of context that you may want to build into your prioritization program is, look for API endpoints that are actually receiving traffic, right? So those are the ones that are publicly exposed, and especially for critical application paths, right? Especially application paths that are in logging mode today. So you want to take that and then look at the Psycode findings associated with those paths, and then prioritize them. So as a general rubric, what I would suggest doing is critical application paths that are in logging mode today. So that's the runtime context. Match them with Psycode findings, prioritize those first. And then when you have time, look at the blocked requests and look at things like shadow APIs and things like this that might be implied by those blocked requests, and then take action in code as well.
Yeah. And so we've been working on this together, and I can share that like from the customers that we've spoke with, like there's a lot of excitement around this new integration. Basically, even like the most basic insight that I can get from Cloudflare, whether something is, internal facing or public facing, whether like there's actual traffic that's being sent to it is kind of key in the ultimate goal, which is like prioritizing the important stuff first. And obviously it gets more interesting if you tell us that there's real text signals, and if it's in alert or in block mode. These all are things that we can use to prioritize really the most important stuff for our teams, and then make sure that they start at the critical things, at the things that they should fix first. And I think like that's the cool value proposition that security products bring when they cooperate. From the posture that we see in Cloudflare and the risk labels that you have in the product, what helps them to kind of understand what should we watch later, what should we fix now. I know we have a lot of like missing authentication, MOLA, like all these type of indicators. So kind of from that perspective, within API security, what are the core points?
Yeah, so I would say, given, like I said, positive security, first line of defense, but when it comes to the reactive side of things, watch for anomalies, things like, broken object level authorization. This is really based on some attacker trying to enumerate values that are associated with some of these APIs, like product IDs or user IDs and things like this. And oftentimes, one of the gaps that we found, both in Cloudflare customers as well as in more public breaches out there, is when there's insufficient authorization associated with individual entities, so to speak, like a given user. So I can actually take Ronan's user ID and then start permutating or try on enumerating other user IDs in the system, try to see if I can get profile information back. That's an example of, BOLA enumeration, so to speak. Again, lack of proper authorization is really the underlying reason. So again, start with these kinds of things that can actually leak data. The gen principle being that these are essentially the runtime signals that are informed by some sort of anomalous behavior on your API endpoints. So that's step number one, beyond positive security. Step two, I generally say, authentication posture, like posture related signals. These have to do with missing authentication, mixed authentication, missing authorization, and things like this. There are about 7 or 8 of these kinds of labels that are also significant that you want to take a look at. We also track sensitive data. Now, sensitive data is just context for you. It doesn't do anything beyond that. But especially APIs that are returning PII, like user information, email addresses, things like this. Those are things, again, from a posture perspective, keep an eye on them and make sure that they are fit for purpose, and take the right steps to mitigate those as well in code. So again, positive security, runtime behavior signals, especially the anomaly driven ones, and then towards the end, the posture signals around authentication, authorization, and sensitive data. All of these exposes labels in Cloudflare.
Very cool. So from Cloudflare, we get like the exposure, the text signal, the posture labels. from our side, we complement it with like the code level vulnerability, the developer that cannot fix this issue. So everything could be routed to the right team. When there is like a WAF or an API security alert, what is a good remediation loop that you can recommend the viewers in our session?
Yeah, so you know, one important detail here is that API protection works in conjunction with our web application firewall. So as it happens, things that we mentioned around the blocking activity for like the default mode for positive security, the enforcement is actually done by the WAF. That is an important detail that I think we glossed over. So that being said, again, depending on the evaluation that you've done, you know, log, tune, followed by blocking action, which essentially means that you're essentially taking action in the WAF, in the web application firewall, with respect to additional controls that you might define. So the granularity can be at the level of individual application, individual endpoints with those applications, and so on and so forth. Again, and then the level of control obviously is um, blocking, logging, those kinds of actions. Also rate limiting as well. So for example, if you suspect bot activity on some of your API endpoints, rate limiting might be one mitigation that you want to keep in mind. So the combination of positive security, the risk labels that I mentioned between anomaly detection, partial management, things like this, and then eventually synthesizing all that data and then taking action through the web application firewall is really what we recommend. And then custom rules are typically what you would do as a result of all this, evidence gathering, so to speak.
Yeah, that totally makes sense. And eventually, I think what this does is eventually it buys our customers time. So you have a security breach, and the edge is what's there to protect you from the active attempts. Obviously, we would always aim for getting like the right issues to the right developers in time to fix it, which is again the challenge that we partner together to solve. Um, so to solve this kind of aspect, I guess like from your experience, how do teams wire this information to the workflow, to Jira, to PR comments, to IDA alert, without like just relying on the WAF and making like hoping that it stops everything that is vulnerable within the product.
Yeah. So again, the key idea here is that in anything that you do with runtime, as Ronan has said a few times before, it only buys you time. So information security professionals, who are the primary persona that Cloudflare sells into, these guys can actually report evidence for you. But ultimately, developers have to take the prioritization suggestions that we were talking about earlier and take action in code. So again, whatever work management process you're using, like creating incident tickets, Jira tickets, and things like this, and then automation around it, is definitely obviously the starting point there. But then again, how you want to use the information today is to have like a principled way of actually prioritizing, like we were suggesting, right? Apply those as part of the automation, going to Jira and things like this. And then last but not least, in the WAF, like I said, the WAF, the runtime protection, it shouldn't be your sole line of defense, because it's a moving target. Attackers are going to be trying new things every day. So exclusively relying on web application firewalls to buy you time isn't the right strategy. You want to examine that evidence, apply prioritization, and then fix things in code, preferably with some automation as well.
Yeah, so the goal is like to turn like this runtime signal into an assigned fix, an honor, change, and remediation. I know we're kind of close to our time, so we started the conversation with talking a bit about AI. So let's zoom back to AI. Um, Essentially, I think like LLM features basically they create a new attack surface, but also a lot of it at its core is API request responses. So obviously, this is something that both our companies monitor really closely. What is kind of the viewing on the AI risk for Cloudflare? How can it help detect and control things like prompt injection and data leakage? Like, what do you see in that area?
Yes, one quick stat. When you look at API protection data, I mean, AI at the end of the day, in part, is also APIs. So what we find from products like API Shield, as part of asset discovery, one of the things that we do at Cloudflare is to identify that you actually indeed have LLM or Gen AI endpoints in your system or application environment. And what we find is that about 5% of LLM endpoints that are served via APIs, they have all the posture flaws that we spoke about, like things like weak authentication, weak authorization, or they expose PII. Right. So obviously, you want to be using your API protection suite, like the way we were describing earlier, to also protect AI as well. Now, beyond all of this is really where some of the, uh, sort of the malicious attempts to use AI is also something that you want to worry about. So products like Firewall for AI from Cloudflare, they're really around, examining the actual payload that goes into your LLM endpoints, so to speak, and then looks for abuse, data leaks, and things like this. Right. So things like prompt injection, which is typically used to break the alignment of your large language models. Alignment meaning you've designed your LLM to respond to specific topics, specific questions that users may have. That's sort of your positive view of the large language model. But what an attacker might try to do is to use prompt injection techniques to break the alignment and get the LLM to produce malicious um, output that's not in line or aligned with your brand and things like this. And or also most importantly, get the LLM to expose private information like user data and things like this. So Firewall for AI as well as some other products from Cloudflare are really positioned for this aspect of large language models as well. And again, Firewall for AI is essentially think of it loosely as a collection of applying existing products like API security, the WAF, and things like this when it comes to data examination, mitigation, and things like this. And in some ways, it's not new, but especially the parts around prompt injection and things like this are very, very specific to AI, which are indeed new. Hence, things like firewall for AI.
Yeah, so I think like from a customer perspective, it's a bit of a good news because the same operational pattern can be used again, right? Like the observe, tune, enforce that you mentioned earlier. Then after we mitigate and fix it with the runtime capability, we can kind of understand the exposure in code and work on resolving it as well. We're at the time for the session, so basically, like just to wrap up, in this new integration that we're releasing, Cloudflare gives the runtime exposure and attack signals that they actually see in runtime. We complement it with understanding the risk in code and ownership, and together we allow our mutual customers to reduce the noise and speed up remediation. Bisham, any last words you want to add from your side?
Yeah, so the integration that Ronan is talking about, again, it's in the early days of it, so absolutely would welcome customers to try it. Reach out to Psycode, to get that started. But generally, what we're talking about, just to reinforce here, comprehensive API inventory, understanding all risks, and then prioritizing using a combination of runtime and, Psycode signals, so to speak, is really the focus of what we're trying to do here. And most importantly, this connection between information security and developers, streamlining that process so that, security becomes embedded in software delivery. Right. So that's a huge part of, I think, what we have accomplished. And we expect this to become emerging best practice for anyone who, puts out APIs and applications.
Awesome. So again, like for anyone here listening, if you want to see the integration between Psycode and Cloudflare, please reach out to either your Psycode or Cloudflare rep, and we'll be happy to show you in detail how this can assist you as well. Basham, thank you very much for attending in our session. Really appreciate having you here and sharing the insights with the audience we have here today. I'll hand it back over to Monica. We'll help close the event. Monica, back to you.